Good morning. My name is Beth Capellis, and I'm the marketing manager here at Triangle Microworks. I'd like to welcome everyone to our latest webinar, a holistic approach to facilitate the IEC 61850 engineering process. This is a two-part webinar series. On May 18th, we hosted part one, which covered 61850 specification and design. If you missed it, please go to our website at trianglemicroworks.com to view the recorded webinar. You can easily find it on our webpage, on our homepage. Today, we'll be discussing part two, which is 61850 simulation and testing. Before we get started, I'd like to go over a couple of housekeeping items. The webinar is scheduled to be 1 hour long. However, we typically get a large amount of questions, so we are happy to stay on longer to answer as many questions as possible. With that said, I'd like to encourage questions throughout the entire webinar. Since the audience is on mute, please submit your questions using the webinar menu under the section titled Questions. You can start asking questions as soon as you have them. Don't feel like you have to wait until the end. We will begin answering questions online as we have several engineers monitoring the questions and responding to them directly. We will also stop a couple of times throughout the webinar to read and answer questions. And then, of course, there will be some time at the end dedicated just to questions. Next, I'd like to introduce our speakers. First, we have Matt Green from Triangle Microworks. Matt is a senior applications engineer here at Triangle. He's been with us for about 6 years and specializes in QA testing with all our simulation tools in Gateway. He is one of our in-house experts on Distributed Test Manager, which is one of the tools you'll be seeing here today. We also have with us Jim Coates, the president of Triangle Microworks. Jim started Triangle in 1994 to provide communication protocol software to the utility industry. He continues as president with a primary role of product research and design. Jim is currently Chief Financial Officer of the DMP3 user group and participates in the IEC Technical Committee 57 Working Group 10. With that, I'd like to go ahead and hand it over to Matt to get started.
Thanks, Beth. So just a little background about Triangle Microworks. We were established in Raleigh, North Carolina in 1994. We have customers all around the world, including equipment manufacturers, system integrators, and electric utilities. Many of our employees sit on the standards committees. These committee members help us keep us well versed in the protocols that we support. We have several categories of products. We have source code libraries for DNP3, 61850, 6870, 101, 102, 103, and 104, TASI2 or ICCP, and Modbus. We provide technical support not only during the initial implementation of our source code libraries, but we also support any of the communication issues that may arise with your device out in the field. You may have also heard of our SCADA Data Gateway, which is our gateway application for protocol translation and concentration. We also have a collection of test tools like the 61850 Test Suite Pro, Distributive Test Manager, Test Harness, and Iron. We will be showing off DTM, which is Distributive Test Manager, and Test Suite Pro today. On May 18th, we held the first part of this webinar series. Today, we'll be taking the SCD file that we created in part one and simulating the substation in DTM. Then we'll verify the behavior and create tests using Test Suite Pro. On July 30th, our next webinar will be about security using Garibaldi. This is the diagram explaining the IEC 61850 engineering process from start to finish. To catch anyone up who missed our first webinar, we created an ICD file or ICD files inside of SCL Navigator. Then we use these files to build up an SCD file inside of Helix STS. And this is the part that we'll be going over today. In the conceptual phase, we will be simulating the entire substation in DTM. Then we can build up test cases and regression tests in Test Suite Pro. Once we're happy with our design, we can move on to the factory acceptance phase. In this phase, we're going to disable devices in DTM and provide those IEDs in the lab. Then we can rerun our test cases from a previous step in Test Suite Pro. In the final phase, the commissioning and maintenance phase, DTM is no longer simulating anything. Test Suite Pro is then brought into the substation and verifies that everything is working properly out in the field using the same tests we designed in the conceptual phase. Another useful application for DTM and TSP is the training of employees. Sometimes you need to be able to train employees in situations where mistakes are acceptable. A simulated environment is a perfect place for this. You can also use this simulated environment to test new equipment before deploying it into a substation. In the last webinar, we designed a high voltage side of a substation. It has 2 transformer bays, 2 line bays, and a bus bar with differential protection. This is the network topology diagram for the system that we designed last time. We have a measurement bay with a bus bar protection and merging unit. We've got our HMI, a test device, and then we have 4 bays. Each bay has a bay controller, a transformer or line protection, a switch controller, and a merging unit. DTM is going to be simulating everything in red, and TSP will be monitoring the substation's behavior. We'll be doing this by importing the SCD file that we created last time. When we import the SCD file, DTM will create a simulation of these functions. Today, we'll be focusing on the recloser function of bay line 1. These are the key functions that interact with the recloser function. The logical nodes corresponding to each function are in red next to them. So I'm going to go ahead and start up DTM and get the SCD file imported. So this is DTM. This is what you're going to see when you first launch DTM. Now, if you have Helix STS installed, there's actually a button that you can click that says import to DTM. That'll jump you all the way to the import section. But if you don't have Helix, I'm going to show you the steps to get there. So you go to File, Import Substation Wizard. From here, you need to select your SCD file. This pop-up is basically letting you know that DTM can now monitor this file. So if you have someone making changes and updating that file, instead of needing to reconfigure your entire substation, DTM can automatically pull in those changes and update the devices based on them. So I'll hit yes, and then I'll hit OK. This is our import substation wizard. Essentially, we have some options up here for what the automatic system is going to create for you. So I'm just going to leave everything checked, and I'm going to import all of the IEDs. So I'm going to click Import Substation and let that run. Now let's jump back over to the PowerPoint for a second and talk about what DTM is doing. So DTM is currently parsing through the SCD file exported by Helix STS. It'll parse through 3 different sections of the SCD file. The substation section is the functional part, including the topology information for the one-line diagram. DTM will be reading this in order to figure out how the electrical equipment should behave together. The IED section contains the data models and the capabilities of all of the IEDs. This is where DTM will gather the information needed to simulate the 62850 devices. The communication section contains the configuration of the communication network, such as IP addresses, which DTM can then use to set up the TCP IP connections for each device. In order to properly simulate a substation, we need to know how these devices interact with each other in the real world. Logical nodes are the functional elements, which are the building blocks for application functions, such as distance protection. Logical nodes communicate with other logical nodes by internal connections or with goose messages. These types of communications are used to implement application functions using multiple logical nodes. To interact with the electrical equipment, logical nodes are wired with physical inputs and outputs. So to simulate this in DTM, we'll need to simulate not only the logical node behavior, but also the internal and goose communications and the behavior of the equipment, including the physical inputs and outputs. We also created a user interface to control the simulation's test conditions, such as fault or breaker failure conditions. To complete this simulation, we'll need a topology and process simulation for high-level power flow. And we did all this by creating a library of logical node and equipment simulations. This library is coded in JavaScript or IEC 61131 PLC programming language. The default behavior will work in most cases, but if you need something specific, you can always customize these libraries. So now let's talk briefly about logical node communication. This is a simplified version of the recloser function that we'll be displaying today. Each of the yellow boxes are IEDs, and the lines completely contained within the boxes are the internal signals, while the lines between the boxes are the goose messages. The arrow indicates which direction the signal travels from logical node to logical node. Later on, Jim will be showing how the signal flow display in Test Suite Pro is used to monitor this communication. So now we're back to DTM. We've gone ahead and imported the substation, so I'm going to close the wizard. The very first thing I'm going to do in this is set up the initial conditions for the simulation. That includes the voltages and the currents and the loads. So I'm going to set those up here in this power. So I'm going to click here and add a voltage. Move down here and I'll add a load. This is another applied volts. So after I set all this up, I can go over to our single line diagram, which you can see here. So let's talk about what was actually all imported in the import substation wizard, and that's all in the workspace. So I'll go ahead and open that up. The first thing you'll see is a JavaScript. This is how we do all of our power simulation. The second thing that you'll see is the substation. And this substation is a representation of the substation section in the SCL file. So at D1, you can see a voltage level. And then down here, we have all of the bays. So we've got line 1, line 2, and the transformers. One more line down, and we have the conducting equipment, such as the VTs and CTs that you can see here in the lines. And if you go one more step further down, you'll see your logical nodes. The next thing we have is the single line diagram, which we're already looking at. And the last thing you'll see is a folder of all the 61850 devices. So what we're going to do now is I'm going to go ahead and right click here and start the simulation up. And then I'm going to go to the power sim and start this script. And what we should see now is we'll see that the VTs are now seeing the voltage on the line, and our CTs are seeing the current that's running through each line. So if I open a breaker on a line, you'll see that current has now gone to 0. But you'll see that the other legs still have their current on them. But if we open both inputs, you'll see all of the currents are going to 0, and the bus bar is no longer energized. So from here, we want to start with our recloser and add in some protection schemes. And that's what these buttons over here are on your right. DTM will automatically go through the substation section and the SCL file and automatically map the inputs and outputs of these internal and goose messages as we described before. But there's always going to be a few things that you may need to go in and customize yourself. So I'll show you how you can do that. You open the substation section and you navigate down to the section that may be not configured properly. And you can do that by looking at the indicators next to the node. So a green indicator means that everything that is required inside of that node is configured properly, whereas orange and red may mean you need to take a look at it. So the first thing we're going to do is we're going to take a look at the differential protection. So you can right click here manage, and then you do manage substation connections. From here, this is our substation connections configuration window. What you'll see up at the top is essentially your filtering options. Do you want to look at the entire substation, the local bay, or just the local equipment? And then from there, you can choose the node that you're interested in. On the left-hand side, this is the sources. And then on the right-hand side, this is the inputs to the node that you're currently at. So I'll choose the local bay, and I'm going to look for the breaker position, because what you'll see here is that out of all of the requireds, only one of them is required, and that's the breaker position. I'll go to local bay, and then I'll look for the XCDR, which holds the position of the breaker. And I'll just grab this and drag it over. So what we should see now is when I hit OK, this will change from orange to green, and sure enough, it did. The next thing we'll do is we'll wire up the PTRC to the differential protection. So I'll right-click here, Manage, and then Manage Substation Connections. From here, I want to find the differential protection that we just set up. So it's still in the local bay, and then I am looking for PDIF1. And what we need here is we need the start and operate commands. So I will drag these over. And hit OK. So now that's green as well. So what we should see here is now I can click this button and that will put a fault on the line. And then the differential protection should pop in and open this breaker here, QA1. And sure enough, it did, and all the currents went to 0. So we did want the recloser function is what we were mainly wanting to show off. So it didn't reclose, and that's because the recloser isn't now set up. So we can go into this breaker and find the recloser logical node. Right-click this, manage substation connections. And we want to wire this to the trip function of the PTRC. So again, we'll go to local bay, find the PTRC, here's the trip, and you'll see that we want to drag this to one of the initiates. So I'll hit OK. So I'm going to reset our simulation now. So we'll see that all of the currents are now flowing, the voltage is applied. Now if I apply the fault on the line, the breaker will open because of the distance protection, and then reclose due to the recloser. Open, and then close. And then the last thing I'm going to show off here is the checkbox right next to these faults will determine whether the fault is permanent or not. So if I click this box here, this means that the fault will be permanent. So when I click on the button, the breaker will open, it'll reclose, but it'll reclose on the fault, so it'll open back up. So this is the general explanation of what we're showing off in DTM right now for the recloser. We're going to pause here for a little while to take a few questions, and then we'll move over to Test Suite Pro to show off exactly what's going on behind the scenes of this simulation.
Okay, we do have a couple of questions that have come in. So let me just kind of start from the top. When testing or simulating the IED, what is considered good practice? Use of a simulator application or simulate these functions, but simulating the logical nodes on an IED?
So when we do the behavioral simulation, that's when we use the substation section. And that's where you're going to see kind of the behavior of each of the logical nodes down here. And that's all being run by the libraries I was describing previously. But if you look down in the IED section, this is where you're going to see the 61850 devices that contains the models and the data attributes, the report control blocks, the goose messages, and all of this is being simulated as well. So I think DTM does both, and they're both necessary if you want to go through and simulate your substation as we're presenting today.
Mm-hmm. Okay, next question. Linking the inputs and outputs of LN inside the simulated IED. So this is the IED process logic. Does this replace the scripting?
No, so this is basically setting up the inputs and outputs to the scripting. Now, like I mentioned earlier, we have that library of logical nodes and equipment scripts. And essentially what we're doing is we're setting up the values that they're monitoring based on these inputs and outputs. So in order for the recloser to know when to initiate its functionality, we need to tie that to the trip signal. But the scripts are all going on behind the scenes.
And this really might just be a continuation of it. It's more of a general question on JavaScripting, but what is done in the JavaScript section?
So we've imported JavaScript into DTM, and you can configure that to pretty much do whatever you want in DTM. It's a full JavaScript engine, so anything you can do with JavaScript outside of DTM you can do. And then we added all sorts of hooks to interface with different protocols, different devices, data types, functions, all that type of stuff. So you can pretty much do whatever you want with the JavaScript behind the scenes, and set those up yourself. So if I right click here, you can just go down to Insight and add a script and make it do whatever you'd like. But what we've done is we've implemented a bunch of commonly used features among the industry and put them behind what you're seeing here in this hierarchy. And that's the stuff that you could go in and edit. So if you right click here, you would be able to edit the simulation node and actually make edits to what our basic behavior is. But the hope is that we're hitting most of the normal use cases for these things, and you'll have to make small tweaks if you have a specific need for your substation.
Okay, next question. Is functional naming possible in DTM? In parentheses, he has ld.name defined in SCL, IED name doesn't appear in 62050 string.
Do we support that, Jim?
I'm sorry.
Yes, we do.
Okay, so yes, I can't show you that right here live on air, but apparently we do support that, yes. Thank you, Joel.
Okay. One of our behind the scenes engineers helping with questions. That's about it for the questions right now. If you want to move on to the next section, Matt.
Okay, so we're going to continue to run this simulation in the background. I'm going to move the simulation off screen so that way there's more real estate for you to be able to see what's happening in Test Suite Pro. But Jim is going to probably still be interacting with it to cause different test conditions in the simulation while he's showing that off. So let me go ahead and set things back to the initial condition. And I should be able to move this over here. And I'll hand it off to Jim. Yeah.
Okay, so this is Test Suite Pro, and we configured it by reading the SCD file that Matt used to create the simulation in DTM. And so we loaded that SCD file and created our own models and mapping of everything that mirrors what's going on in DTM. We could have also done that by scanning a range of IP addresses and doing a discovery of each IED that we found. So on the left side over here, we have tools like data miner that's used to find the data. And then on the right side, we have displays that are used to display the values of those data things that we found over there. The displays that we'll look at today to analyze the simulation that Matt created are the signal flow that we're looking at now, the logic analyzer, the report viewer, the goose viewer, and the test sequencer. Then after we take another break for questions, we'll come back, we'll take a quick look at the custom display and some of the other tools over here. So on the signal flow diagram, the IEDs are these big boxes, and then within that you have logical devices, and within those logical devices you have logical nodes. The connections that go between IEDs are goose messages, and within the IEDs are internal messages that we can get through reports. So if we start a capture here, I can then go over to DTM and cause the differential protection fault. And you'll see these lines, the yellow lines are the goose signals being transmitted. The other gray lines are the internal ones. The black ones didn't change. Down here on the timeline, you see the events that occurred. And so if we stop recording, we can go back and play through those events slowly and verify that they occurred in the order that we expected. So there's the differential protection event, differential fault that I caused. That causes the PTRC, which causes the breaker to open. Then you see the signals going back false. Now the recloser kicks in, which is then going to open the breaker again. Then we see those signals going back false again. And so if we hover on these signals here, we'll see kind of a little event history of changes on that data attribute. And if we select these, if you select one of these signals, you'll see that the timeline only shows those signals, only the events for the signals that you've selected. So we can select multiple signals down here, and you'll just see the events for those signals. We can also right-click and send these selected signals to another display, such as the logic analyzer. We can use the logic analyzer to evaluate the timing on these signals. If we go over to that, we can use we can drag around to find a different portion of the signals that we're interested in, and then we can use the scroll wheel on the mouse to zoom in and see more detail. So the top signal here is the differential protection goose message that we saw come in. Then that triggered the PTRC, the XCBR then opened, then the recloser, then the CSWI to close the switchback. And we've got these cursors on here that we can use that will show you the value of the data item where they are. So like right here, you see on the auto recloser status, you see the value shown right here. It went into trip protection, and then if we keep sliding over, you'll see the different states that it progressed through, in progress, and then over here, if I can get far enough over there, you should see it go back to ready back here. And what this is doing, it's finding the nearest event and highlighting the value at that event that we received. So the times that we're seeing on this axis are all from the goose or report messages that we received over 61850. So the timing is not based on the PC, it's based on the accuracy in the device that we received the 61850 communications from. So the other thing we have here is a goose viewer to look at those goose messages in more detail. And right now we're grouped by the IED, and within the IED we see the different goose streams that are available in that IED, and then these are the messages that we received in that time frame. And I can slide this divider over here to give it a little bit more room. And if I select these messages, you'll see the values over here. These are the data attributes, and each of these columns is a value over time that we received in a different message. So for example, on the recloser, we saw that in this message it was originally false, here it became true, and then it went back false. And so you can scroll this window over to see the values from as many goose messages as you like. The report viewer works pretty much the same way. You've got your IED, the report within it, and then the different messages there. Okay, so if we go back to the signal flow, this is the sequence of signals that we saw for our recloser event, and we use this to visually inspect what was going on with the recloser function. If we want to automate that testing, we'd go over to the test sequencer. And we can see all the steps here that we can generate graphically. And then here's more of the details on exactly what we're doing, such as timeouts and triggers and so forth. And then here will be an execution log. So to create one of these, we have a couple of different options. We can just create a new one. And then come back over here to data miner. Grab the wrong slider. There we go. And if I just grab any random data, I don't really care what it is. We'll get a dialog box that shows you the functions that we can do. We can verify that that data attribute has a specific value. We can write to a configuration option to change the configuration value. We can do control operations. We can also get a dialog box for a user action. We can do 61850 actions such as connecting or disconnecting to a device. And then we can also interact with external test equipment such as a Mega to put, say, the simulation voltages that we've created on our simulation network. We could put those out to the Mega so a device under test that we're interfacing with receives that voltage. So with this, we can create test sequences that could be used later in the process. We can develop them on the simulation and then use them at, say, factory acceptance test or the site acceptance testing. And then those will be automated so that we don't have to step through them manually. So that's how you create a test manually. We can also take this sequence here from that we captured in the signal flow diagram and send that to the test sequencer. And that generated steps here in the test sequencer for each of the signals, each of the events that we saw in the signal flow. So here you see the differential protection going true, you see the PTRC going true, you see the breaker opening, you see the differential protection going back false. And so you follow each of these events in sequence and verify that they occur in that sequence. Some of these signals going false end up getting an erase condition, and so what we need to do there is merge those into one step that they could occur in any order and it won't cause an error when one comes in before when you're running the test. So again, this is a test step. If we had checked this box, validate order of events, it would verify that this one came before this one, but since we didn't, these could come in any order. So if I go back over to DPM and, well, let me start the execution of the test first. And I go back over to DPM and cause a differential protection fault again. You'll see this guy running automatically through there. And this is what we found in our testing. This is why we do the automated testing. This PTRC didn't generate. We have an intermittent problem there, which is why you want to do the regression testing to keep running through things again and again. I bet if I run this test one more time that I could make that run successfully, since it's an intermittent problem. So that time, all of the tests ran successfully. So we need to look into why this signal is periodically not acting correctly. And that's what the value of these regression tests is, you know, when you're integrating the new equipment in, working with DTM, you disable that device in DTM, put the real equipment on the line, and then it can interact with all the equipment and see if you can pass all these regression tests again. Okay, back on the signal flow, if we're looking at different functions, we drew this diagram for the refloser function. If we wanted to have a different layout to look at, say, a breaker failure, we could look at that diagram and evaluate the breaker failure operation, see how we have the breakers from other bays in here. This is the breaker that we were looking at. So this is the differential protection that will generate the PPRC and then generate the breaker failure signals for the other bay. So depending on what we want to look at, we can have a whole slew of different signal flow diagrams here. And we can generate, we can save captures of those events by storing them in this snapshot buffer. So if we see something in the field that we want to show to an engineer when we get back to the office, we can save that and then play it back later. So for example, we select that one and then we can play through it. So one more thing that I want to cover before we get back to some questions is the way we find data. Normally, a 62850 client is going to show data as a model view with a tree where you expand out different. Oh, I'm going to cover this afterwards. I'm sorry. Why don't we stop now for questions, Beth?
Okay, yep, we do have a bunch of questions coming in. Let me try to take them from the top. In test sequencer, do we verify time of event occurrence as it could be delayed, which may not be expected?
Right now, we verify the order of the events that occurred. We could, yeah, you could drag a timestamp over and validate the timestamp with a certain value.
Okay. Next question. And the signal flow, is it created automatically when you get the ICD?
At this point, no, but I will cover how like what you're developing here is different functions, right? So you're going to want to, like what I'll show later is that if we drag over this CSWI, it will automatically pull over the subscribers to it, like this XCBR, and the inputs to it, like this recloser. And then once you get that basis there, you can right-click and get a context menu here and see what other logical nodes subscribe to this message, or I'm sorry, that this device subscribes to, and then click here and look at the other subscribers to this signal. So it's fairly easy to expand out the functionality that you're looking for to test. What we'll probably do long-term is take the data that we came up with to create the simulation in DTM and then have different schemes that we can apply those to. So you only draw like the recloser function here or the breaker failure function here and just isolate. So you don't have this big diagram that shows all of the goose connections in the entire substation, because that can get overwhelming. You want to isolate it down to a list of specific functions that you're focusing on testing today.
Okay. Can Test Suite Pro be used to event fault record on a live system triggered by a goose event, for example?
I'm sorry, could you repeat that?
Sure. Can Test Suite Pro be used to event/fault record on a live system triggered by a goose event, for example?
Yeah, so Test Suite Pro in the commissioning and maintenance phase that we were talking about during the engineering process definitely can be taken into a live system and have these same tests run in the actual substation. The triggering options to start the signal flow in our other tests, I mean, obviously there's the record button, but for the test sequencer, when you run a test, you can put a variety of time starts or how long you wait for each step. So you can definitely set it up for Test Suite Pro to kind of autonomously sit there and monitor values and then be able to run the tests on it later once you trigger certain test conditions or if the system triggers out certain conditions as well.
Okay. Does the report viewer in Goose Viewer provide all details like Wireshark MMS packets?
So we've tried to filter down the information that most of our customers are most interested in with the report viewer and the goose viewer. This is for people who may not feel as confident digging into every single message that you'd see in Wireshark. So if you open up the report viewer, if you open up the goose viewer, you're going to see the individual, goose streams. You're going to see the reports that are coming in, the values inside of them, the timestamps, the qualities, all those important 61 and 50 bits. But you may not see absolutely everything that you might see in Wireshark, but that's because we're really trying to filter it down to the stuff that is most necessary for the engineer on site.
Okay. This is kind of going back to DTM. Do you have a transitionary simulation on DTM? I'm not sure if we might need more clarifying information. Do you have a transitory simulation on DTM?
Christoph, you got any insight on what a
Transitory simulation on DTM.
Can you repeat the question? I was answering as a question, sorry.
Do you have a transitory simulation on DTM?
What is meant with transitory simulation? I mean, we have transient data objects in 61850. They can be included in this simulation as anything else. I'm not sure what otherwise could be meant with transitory simulation.
Yeah, whatever question's being asked here, can you give us a little bit more qualifying information?
No, I think what they're saying is that if you get a pulse, a short pulse signal, where a signal just goes true for a very short period of time and then goes back false, yes, we would catch that because that would be a goose signal.
Mm-hmm.
And we would display that in, all of the logs with various tools.
But if we're not answering the right question, feel free to clarify it, and we'll either tackle it in the next question section or definitely by the end of the webinar when we're going over just questions.
Mm-hmm. Let's take one more before we get back into the presentation. Can test sequencer be programmed to run repeatedly and output results to a report?
It does have this execution log that we can output. You have a test plan here that has a group of it has a test group within it, right? You can add tests and test groups and test plans, and then you could run a test plan that ran a whole series of tests within it. And then the output from that you can export as well. See export results.
And you can add as many or as few tests to that test plan as you want. So for the respects of can you continuously run it, you could just re-add the same type of test to the point where you've got 10, 15, 20 of them. And that way you can vary the exported results to make sure, over time, is your test consistent? Are you getting the same results each time, or is something varied?
Yeah, I think what we might want to do is add like a configuration on this guy where you can put a counter. So if they were doing like burn-in testing, in a heat chamber, you could execute this test just repeatedly 100 times or something, so they could run it overnight. And that test would keep running, and then give you the results in the morning.
I would say with that, let's go ahead and put, continue to ask your questions online, and we'll continue to answer them online for to just stay on time if you guys want to get back into the demo.
You bet. All right. So like I was saying before, most clients display the 62050 object model as a hierarchy. And so, and also there's a lot of data in here that you don't really care about when you're just looking at the process data for the, when you're debugging things like this. For example, the descriptions and the configuration values for various parameters. So on our advanced client, we will show the value here and how it was read. Some of these, especially configuration parameters, will only be available from the SCL file. Other ones we get by goose, and other ones we get by report. And then if we don't have it in a goose or report data set, then we can just read it, and that would be polled. But what we've done in order to find the data easier, we've created a tool called Data Miner that filters out all of the, that only leaves the process data so that you see the data that you're interested in. So each row is a data object, and the columns are properties about that object. And so we can filter out stuff that we're not using. For example, we have a property here called used in a goose or report control block. And if this column is checked, I can filter based on that to only see data that was actually used in this substation design. Because there may be a lot of data attributes in the SCL file or SCD file that was used to create the substation that were not actually used for that substation design. We don't have to weed through those to find the data that we're looking for. So this filter was created to find the signals within that I might use for a signal flow diagram. And so I can take a column here and bring it up and group by a bay, and then by the logical device name, and then by the logical node name. And so that's what I've done here. And so these are data objects within that logical node. And then, so these are the properties this one has. So if I want to see what the external references that this data object has, then I can navigate to them right here. So for example, I could navigate to the recloser, and it'll find that for you. So you can see the inputs and how data objects are related to each other very quickly in here. The same thing for subscribing logical nodes. You can look at who subscribes to this guy. You can put that in a column as well if you like. So once you find a layout that you like, you can save it as a preset up here. For example, this is a preset that I created for drawing one-line diagrams. It's going to have grouped by bay and then by logical device. These are all the devices within the each bay of the substation. So it's real quick to find the things you need to draw the one-line diagram in the substation. So if before we had a question about creating a new signal flow diagram. So if we create a new one, and we grab, say, this that op close, when we bring it over, it's going to bring over we brought over the CSWI. It brought over the XCBR as well, and the inputs to the CSWI, the recloser and the sync check. Then we can go here and add an input to this guy. Shows you all the inputs that we have. And so I can add the other op close signal. We can also look at the output. On it. We can look at who subscribes to it and say add the breaker failure. So, let me move that back into the. It's part of this IED, so it's a different logical device within this IED, so it draws in the same box. And so you see that output, it gets drawn and it adds the logical nodes that are required to do that. So you can quickly expand on the drawing that you have in signal flow and look at what other signals are available. Like I could look at this guy and add other inputs to him. Looks like we've already got them all. So you can kind of explore and see how you want to expand this signal flow diagram. So if we look over at the custom display, That's going to mirror the one-line diagram that Matt had automatically created in DTM. And if we zoom in on this a little bit, you can see it a little clearer. So here's line 1. This is transformer bay 1. This is the breaker. We can open and close and switches. And data objects in here, like if we go to the measure end, when we draw things on this diagram, say I want to put the phase voltages over here, see how that draws 3 data attributes at once instead of having to pull those individual data attributes over. So another valuable tool to see what's going on in Substation is Goose Tracker. So the rows in this chart are the goose streams that are available in the substation. And the columns are properties of those goose streams. And so if we, if I go over, well, I'm not going to try that because we're getting short on time. So like right here, for example, the SCL wire match column, if you want to see what that is, you hover over the column heading and it'll give you a tooltip that explains what it is. And it'll also explain what errors it can cause in this status column right here. So the status column tool header also shows what columns it will generate, will change the status value here. So we've grouped by the status column here, so it brings the important errors to the top so you can see anything that's wrong in your substation very quickly and verify that signals that maybe a device is not receiving or something are there and that they're not having problems. So if you notice, one of the signals here has a warning on it, and it says that the simulate bit is set. The reason that's set is because in our Goose publisher here, we were publishing that simulated signal. If I want to change, so this contains a list of all the Goose streams available in the substation that we could simulate, and you expand it out to see the data values here. If you want to change one of the data values that's on the simulated stream, you can just change it like that and then publish the new Goose message containing that data. It will then continue to be retransmitted. If you wanted to publish a real stream instead of a simulated stream, you could change these checkboxes to publish a real stream in case you needed a signal from a device that you didn't have presently and you didn't want to simulate that whole device in DTM. So I'll before I wrap it up and give it back to Matt to go over a few more things in DTM, I just want to mention that we can also do a compare model. We can go out and do a discovery of a device on the network and verify that that matches the SCL file that we have loaded in Test Suite Pro. That saves a lot of problems when you've got version problems. You're wondering if the right data is in that IED. The other thing that can save some time is SCL verify. A lot of problems in 62850 are caused by errors in the SCL file, and this will check the syntax and make sure everything is synced up in the SCL file and that you're not getting invalid data in. So with that, back to you, Matt.
Thank you. So one question that I'm sure we're hearing a little bit of is we talked about the SCD file, the substation section, the IED section, all that stuff. And some people might be saying, well, what if I don't have that fully configured? You know, can I still run tests in the simulation with DTM? And the answer is yes. So I'm going to ignore the substation section as of now. And I'm going to show you other ways that you can change data in DTM. So I'm going to go straight to the 61850 devices in the IED folder. And what you can do from here is you can right click and do simulate. And these gives you your different ways that you can simulate data. The first one I'm going to say is just auto data changes, and I'll just show you what that is. What that's going to do, since I did it at the folder level, it's going to look in that folder and find all the devices, and that's 19 61850 devices. And it says, do you want to create the default data points for all 19 devices? That's going to be anything in a data set. So I'm going to click yes. It's going to go ahead and populate all the points. And what that's going to do is it's 119 or so points in this substation that is a data set. And what it's going to do is it's going to change these variables, these data attributes. And essentially, it's going to change it in a way where like the user doesn't really care. So it's going to toggle binaries on and off. It's going to increment integers and analog values up until a certain point. It's going to go through the different states of double bits. And what you're just trying to do here is you're trying to generate traffic. And you can do that by on an individual device level or at the whole substation level. This allows you to verify that goose messages are being sent at the right intervals, that reports are being reported, that your devices are basically functioning at a 6150 compliant level. You can change this with the sample interval. So right now it's going to change all this data every 5 seconds. But you could come in and change it, say, down to every 2 seconds or so. That's normally what I do. Of course, you can open these things up and add and remove values as you want. You can drag new things in from the model into here or drag things out. You can insert all the MXs, all the STs, all the data sets like we did before. Once I hit OK here, that's going to go ahead and put a hammer at the folder level, but it's also going to put a reference node at each of our devices. So you can actually start this at a single device, or you can do all of them at once. And the other thing I'm going to briefly go over is a little bit closer to simulating behavior. You can add a CSV file. And so if you add a CSV file, what you'll need to do is import it, which I've got this breaker position CSV. And what this is this is a CSV file that has different columns as your states. So you can say when say state 1 is breaker open. So what you can do with that, which I can just right click here and do apply state. In this, I have breaker open, in between, and closed. So what you can do is you can time up certain data attributes that make sense together. So when the breaker's open, the current should be 0. So you would put the breaker in the open state and the current at 0. In between, the current's still going to be 0, but you might be in an intermediate state for the breaker. And then once the breaker's completely closed, then you can then set the current to run the specific amperage that you need. So there are other ways that you can do these simulations. Of course, you could go in and write your own JavaScript as well, but we're not going to go into that for this webinar. I'm going to jump back over to the slides and hit the last few things before we start to wind down and answering questions. So in the last 2 webinars, you've seen our SCL Navigator, our 61850 Test Suite Pro, and Distributed Test Manager. Navigator was used to create and verify ICD files. DTM was used to simulate the entire substation and create testing scenarios for device behavior. And Test Suite Pro was used to monitor, troubleshoot, and test simulated or real substations. We actually bundle all 3 of these applications together and sell it as our IEC 61850 toolkit. And if you're interested in the 61850 engineering process, we highly recommend looking into this. So just in case you came late or you want to review what you saw today, we do post all of these webinars to our GoToWebinar page and our YouTube channel. We also have handouts in the GoToWebinar app that you can go ahead and download for product information, more information about Triangle Microworks. And soon we'll be opening up a beta for our next system toolkit release. And if you're interested in what you saw today and you'd like to participate in that beta, please let us know on the survey that you'll be getting after this webinar. As Beth said earlier, we are going to stay online to answer questions. But if you have to leave early, feel free to drop any of your questions or comments at sales@trianglemicroworks.com. And with that, I am going to open up the floor to questions.
Okay, well, we've had a lot of good questions come in throughout the whole webinar, and I see a lot of good answers going back out online. So yep, I will try to get through as many of those as possible for anyone that would like to continue to stay on. The first question that we have here, or the next one is, can we build certain logic in test sequence using verify to verify a switch, or if logic to verify DA, and do write control certain actions?
In which display or tool were they talking about?
That is Test Suite Pro Test Sequencer.
Yeah, so you can monitor all sorts of values in that, and you can also perform writes as well from there. I think Jim kind of showed that off a little bit, where you've got the verify, you've got the writes, and you've got several other things that each test step can do.
Okay, I have a question here that I think goes back to DTM, but perhaps it can be answered on both tools. If we simulate all devices in a single, how the network latency or delay taken into consideration? I think it just lost it. Is that possible to simulate devices in a multiple PC or run test sequencer in a PC?
So yeah, so we've been referring to it as distributed test manager. We actually have a lot of training and information on our YouTube channel as well, but the reason we call it distributed test manager is because for large systems or for specific systems, you do need to distribute the load, right? Which means that we can take all of the devices that we simulated, instead of just doing it on my laptop like I did today, you can actually set up multiple computers and distribute the individual IEDs to each computer. That will be able to better simulate things like if you want to test your network, or if you have such a big substation that maybe one computer can't simulate it all together. Maybe you need to go across some specific hardware or simulate things in a more realistic situation. Yes, you absolutely can distribute it to as many computers as you need to get your proper test in.
Mm-hmm. And to kind of follow up on that question, Matt, it's related to this next one. Is there any limit in the number of devices that can be simulated?
So there are two limits. The first is your resources. So if you have a computer from the early 90s, you're probably going to be able to simulate a far less amount of 61850 or any protocol devices on it than if you got something that's much more modern day. That kind of relates to what we were just talking about. If you have multiple computers, you can then distribute that load across multiple of them, allowing you to simulate more devices. Also, the device count that you can simulate in DTM is a configurable option for when you purchase DTM. So I think the trial, when you download a trial for it, you get 25 or so devices by default, but you can up that number to whatever you're interested in. So if you don't need 1,000 devices, you can save yourself some money. If you do need higher device counts, we can scale it that way as well.
Okay. For DTM, in terms of timing accuracy, do you measure the latency and jitter of the simulated goose messages? There must be some difference between simulated goose from a PC versus actual goose messages from an IED. Any comments?
So yes, we have, so DTM solely runs on Windows applications right now. So we do have some sort of restriction when it comes down to the timing requirements of Windows. That being said, where we can, we monitor timestamps and things set by the 61850 device, and we try to be more accurate with timing based on those type of parameters.
Okay. Sorry, we've got a lot of questions coming in, so it's jumping around. Okay, how buffer and unbuffer information really work in IEC 61 is completely based on the FIFO concept. How does this really work when a controller is working as a client and a relay is working as a server, where information goes to the SCADA through 104 communication protocol? And that might be, we might have to call in one of our engineers that are working behind the scenes on that one. Matt or Jim, just let me know.
Could you repeat that question one more time?
Sure. How does buffer and unbuffer information work in IEC 61850? It's completely based on the FIFO concept. How does this really work when controller is working as a client and relay as a server, where information goes to SCADA through the 104 protocol?
So we implement both 61850 and the 104 protocol you're describing through our source code libraries. So the simulation tool of DTM isn't really just pulling up smoke and mirrors and pretending like we're simulating devices. We're actually simulating based on the stack that is out, and plenty of devices all around the world of customers who use our stack. So we actually simulate 61850 down to its spec requirements. So if you set up a buffer control block or an unbuffered report control block, it's going to work as if it would in a physical device. The exact same concept can be said for the 104 protocol that we use. So I think the answer is it works just like you would expect it to.
Yeah, so if a data attribute or a data point in 104 changes in the simulation, then the stack will monitor that event, put it in the buffer, and then send it out just like it would if it was a real device. And then the client that's receiving that would process it just like a regular client would.
Okay, I've got a specific question here on a use case, and basically they're asking if DTM can be used in this purpose. I'm looking to upgrade a currently serviced substation, which is using 62850 goose messaging for the substation interlocking. As I will be upgrading IEDs on a bay-by-bay basis, I will need to simulate goose to support the existing interlocking system, maintain goose quality bit, as each bay is upgraded. Can I use DTM for this?
Yeah, absolutely. That seems like a really good use case for both DTM and TSP. That's one of the things it's designed for, is upgrading old substations to more new equipment. So absolutely.
Great. I've got a question here, Matt. Maybe we can touch on one of the past webinars that we had done. He's asking, is there going to be a webinar for the SCADA Data Gateway?
SCADA Data, yes.
Now, I know we did.
So we've done a few things that have had Gateway kind of running in the background, or as the device under test, but there hasn't necessarily been a webinar specifically about Gateway. We are constantly reevaluating what is going to be in our next webinars, what we're next going to be talking about. And Gateway is a very popular application here. It's used all over the world. I would not be surprised if there isn't something coming down the pipeline.
Well, we had the past webinar where we showed how DTM and Gateway can work together in testing your Gateway. So certainly I can send out a link to that individual of that past webinar where it did show, put our Gateway a little bit on display.
Yeah, it showed off the performance and activity of Gateway as the device under test.
Can DTM be used to test buffered reports? Yeah,
absolutely. I think Jim and I were talking about that with a few questions back. But yeah, so one thing I like to say when I'm giving demonstrations and trainings is, as far as the outside world is concerned, if you bring up Wireshark, if you bring up any sort of sniffing application, all the protocol traffic you would expect from a device is going to be seen on the wire. It's as if the physical device is sitting there right next to your laptop, just talking out of whatever IP address or port number network configuration you provide it. So 61850 supports that, and so does DTM and TSP.
Okay. We still got some questions coming in, but I think we've answered most of them at this point. So I think for now, I think we're good to wrap it up. What I would mention to everyone is that once we do close up this webinar, you will receive a survey. It's just a 5-question survey. We'd love your feedback. Please go ahead and answer that. Whoever does answer the survey will also receive the PowerPoint slides that we have here today. And everyone, whether you answer the survey or not, will get an email with the recording to this webinar. Please stay tuned for our next webinar. We're scheduled for July 30th to address, to really show off a new security product out there called Garibaldi. So stay tuned for more information on signing up for that webinar. And with that, we thank everyone for their time, and we will be following up with additional information if you respond to the survey. Thanks, everyone. Take care.